is Aishwarya from EC department. I welcome you all for this session. It's about non-inverting amplifier. It is an application of operational amplifier. So, non-inverting amplifier means it is the one of the terminal in the operational amplifier and it will amplify the signal without any phase shift. That is what it is called as non-inverting amplifier. So, let us start with diagram and derivation. So, we all know that this is our operational amplifier having negative and positive terminal. Negative terminal is going to indicate the inverting terminal and this positive has to be non-inverting terminal. So, in this condition, I just grounded the inverting terminal here. Okay, I just grounded here. Next, I will apply the input here as V. Okay. Then I have to connect this feedback circuit because of to find the closed loop condition. So this is about our RF, Rin and R1 and R1. Okay. So now we have to calculate the current value at node A, and that is input side and output side. So by using this diagram. Okay. So at node A. I told you what is that VA equal to VB. So now here in this VB having the voltage is V in. So whatever here same values here, that is this VA equal to V in. VA equal to V in. So VA equal to V in here. So now at node A. So in this non-inverting amplifier, firstly we will calculate the current flow is like this. Start from here and flowing through this. So I have just apply the value here. Then the current flow is like this only flow. Okay. So now I have to calculate the output side. So that is what I equal to V naught minus V in divided by RF. Okay. So that is right here. V naught by. This is what our equation 1. So next one is we have to calculate this input side current. That is this. So current starts from here to here with respect to this resistance, and now here to here with respect to this R1. Okay. So I write it here. I equal to V in minus 0 because this terminal is grounded here. Okay. So 0 divided by R1. Then V in by R1. This is about our equation 2. Okay. Now we have to equate equation 1 and equation 2. So 1 equal to 2. So now we just applying this value here. So V naught minus RF minus V in by RF, that is equal to V in by R1. Okay. So now I just transfer this value into here. So V naught by RF equal to V in by R1 plus V in by RF. Okay. So now the common terminal is V in. So I write it here as 1 by R1 plus 1 by RF V naught by RF. Okay. So now V naught by RF equal to V in of, we just cross multiply this. It is R1 plus RF by R1 into RF. Okay. So now I just write it here, this RF. So V naught equal to V in of R1 plus RF divided by R1 into RF. This RF will be cancelled. So the output of V naught equal to V in of, this term going to be 1 plus RF by R1. So this is what about our non-inverting amplifier output. Okay. Next, by using this, we have to find the gain value. So G equal to output by input. So V naught by V in. So the value is 1 plus RF by R1. So this is what the gain value of non-inverting amplifier. So next we will draw the waveform. So here is the waveform. This is our V in. I just applied 2 volts to the input, and after processing I will get the output like this. So this is just the amplified value here. So 0 minus 2. This is what your V naught. So this is what your waveform of non-inverting amplifier. Okay. So firstly we have to draw the diagram, then calculate the current value, then equate that current value, then only we find the output voltage like this, and after that we have to write the gain value, that is V0 by Vin equal to 1 plus Rf by R1. Then we write the waveform. Okay, thank you.